Okay, so last thing of this week is the two sample t-test. Okay, so two sample t-test, we're comparing two means. We're saying that one mean could be different than the other mean, one mean could be higher than the other mean or lower than the other mean, right? So the null hypothesis here I can build as mu1 minus mu2 equals a certain value. So if it's 0, means that they are exactly the same, or I can say that they are higher, lower, or different than 0, right? Or you can just write mu1 equals mu2 or mu1 higher, lower than mu2, right? And depending what it is, it's going to be a one-tailed t-test or a two-tailed t-test, right? As you guys know, just explaining the other video, is just that the comparison value, the critical value will be different, right? This is how we do it by hand. We don't need to do it by hand, but this is how you would do it. Okay, so let's take a look in our Excel file. So here we have the two sample t-test. It's the t-test of mean difference that the table. Let's say we have two lines of Coca-Cola bottling. We have line 1 and line 2. We want to know if they are different than each other, right? So the null hypothesis will be equal, right? Line 1 equals mu line 2, and the alternative will be that they're different than each other, right? So here again, you have just the math being done. You have the formula, the mean of line 1 minus mean of line 2 divided by the standard deviation divided by n plus standard deviation divided by n, the square root of that, and we get to that t-statistics of 99. Degrees of freedom is the sample size of one line minus 1 plus the sample size of the other line minus 1. So we have 10 and 10. So 10 minus 1 plus 10 minus 1 is 18. So this is where you look at the degrees of freedom here in this column, so 18. And then if we're doing a one-tailed or two-tailed t-test, we're doing a two-tailed t-test. So our p-statistics critical value here is 2.1. Okay. We can also do the test here in Excel. So to do the test in Excel is the two sample assuming equal variances, right? This is the test. To do that, we need to go to data and go to data analysis toolpack and do the t-test. So we can say assuming equal valences or assuming unequal variances. So if I don't know the variance, I can use this one, which is the most robust one, assuming unequal variances. And then I have to capture range 1, so we have to select the data here. Range 1, I did the example assuming equal variances, right? So you can do one or the other one. It depends on what the problem is telling you to do. So let's do the same one as the example, assuming equal variances. So I will select this data set, range 1. I will select this one. The range don't have to be the same. Don't have to be the same number of n. So the number of observations, the difference will be 0. I didn't put any labels. My alpha will be 0.5, and I will do in a new folder here. I'm clicking yes, and it creates a table like this, which is exactly the one that we have there. Okay, so what is this telling me? It's telling me the t-statistics was 0.98, and here you have the two answers for the one tail or two tail. So Excel doesn't know if you were doing one tail or two tail. It's just presented to you. So the critical t is 0.98. If you're doing one tail, the critical is 1.73, so that's lower than this. If you're doing a two tail, was 2.1, which is the same value that we looked on this table, right? Remember the 2.1 here, okay? So we're doing the 2 sample t-test, so this is our critical value. Our t-test p-value here, it was 0.34. So 0.34 is higher than 0.05, so we cannot reject a null hypothesis. We can only reject if it's lower than. Okay? So basically, we're saying that the possibility is 34% that these are actually the same, have the same mean. So it's not less than 0.05, so we cannot reject the null hypothesis. Okay? Again, remember the critical value here, if it's within minus 2.1 and 2.1, it means that I cannot reject the null. Okay? So now we've done this one. Let's go to the practice problem. So in the same table, you have this practice problem, evaluation of 8 engines, old and 9 new types, following that same example of nitro oxide. We want to perform the test, assuming equal variance and not assuming equal variances. You can do both of them just to take a look. We're going to use usually the not assuming equal variance is more robust if we don't know what is the t-statistics. What is write down the alternative and the null hypothesis, and can I reject the null hypothesis, yes or no. Remember that the data is all here. Okay, we have the old and the new, we have the t, we have the value, can we reject it or not. So now I want you guys to, this is the last video of this week, so after this video, you go and do it by yourself. I'm going to do that in a mini tab in class just to show you how to do it, but it's very easy and very simple. So now I want you guys to do it and see you in class. Again, I'm not going to do it, I'm just going to solve it in class. I'm not going to give you time in class to do any problems.